Hey friends, this is our own YouTube channel Electrical and Electronic World. So friends, today we are going to see what is a rectifier, how to do simulation of rectifier, and how to use oscilloscope and many more interesting things. So let's begin it. Basically, rectifier is a device which is used to convert a sine wave into a pulse DC, and again using a filter capacitor and voltage regulator we can convert into a linear power supply which is used to power any DC load or charge a battery source. So friends, let's see how to build it. So friends, let us select a component that is required to convert 220 volt 50 Hz AC signal to 12 volt DC supply. Basically friends, we will require one sine wave, one transformer to step down 220 volt to 12 volt AC supply, one bridge rectifier to convert sine wave to pulse DC, one electrolytic capacitor for filtering output, one 7812 IC for constant 12 volt DC supply, and LED as a load. So friends, as we have selected our all components, now we will go for placing that components one by one according to their sequence. So friends, as we have placed our all component one by one, now we will also place virtual instrument like voltmeter and oscilloscope to measure a voltage and see a waveform. So friends, as we have placed our all components as well as virtual instruments according to their sequence, now we will go for simple connection of our components. So friends, the output of sine wave will go for the input of transformers for the step down purpose. The stepped down 12 volt output will go for the bridge rectifier for converting into AC signal to pulse DC. Friends, as we need a linear voltage supply, we will connect the output of bridge rectifier to IC 7812. The output of 7812 IC will go for the positive supply of LED. The negative supply of LED will be connected to negative supply of bridge rectifier and also to ground. Friends, as we want to filter our waveforms, we will connect two filtering capacitor. The C1 will be connected to pin number 1 and ground, and C2 will be connected to pin number 3 and ground of 7812 IC. Friends, as we also need to measure the input voltage and the output voltage, we will connect two AC voltmeter to input and output of transformer and one DC voltmeter to the output of load. So friends, as we have completed our all connection, now it's time to assign the value for our components. For assigning the value for components, just double click on it. Friends, as we need a 220 volt RMS signal, we will change amplitude to 311 volts and frequency to 50 Hz. You can use this formula to assign the value of any RMS signal. Now let us change the value of primary inductance and secondary inductance for step down purpose. The primary inductance of transformer should be 1 Henry and secondary inductance should be 0.003 Henry. Friends, as we use the two capacitors C1 and C2 for filtering purpose, we will assign the value of C1 to 1000 microfarads and C2 to 10 microfarads. So friends, as we have completed our all circuit, now it's time to connect the oscilloscope to it for checking the waveforms. The oscilloscope terminal A will go to the input of transformer, the oscilloscope B terminal will go to the output of bridge rectifier, and C terminal will go to the load. So friends, as we have completed our all circuit, now it's time to simulate it. For simulation of our circuit, just click on play button and see the magic. Basically friend, our oscilloscope does not show any waveform because we have not set it to a desired setting. For the setting of our oscilloscope, put A terminal to AC signal because we have applied to sine wave, and B and C terminal to DC signal because we have connected it after the bridge rectifier. Friends, as we can see, our sine wave is converted into pulse DC signal at output of bridge rectifier, and pulse DC signal is converted into linear supply as the output of 7812 IC. Friends, we can also adjust our volts per division of oscilloscope by using this knob, and x-axis using this knob, and y-axis using this knob. Friends, as we can also note down our voltage, that 220 volt is converted into 12 volt as output of transformer, and we are just getting 6 volt at output of load. Friends, as we want 12 volt as output of load, but we are getting a 6 volt, this is because some voltage is drop across this LED. So friends, now let us see what happens when we remove two filtering capacitor from our circuit. To remove any object from our circuit, just right click on it and click on delete object. So friend, as we have deleted our capacitor, now let us see the waveform. Friends, as we can see, our output contains lot of ripple waveform, and this ripple wave is sufficient to damage your any electronic circuit easily. So friend, in this circuit, the value of our capacitor is very important to us. Hope friends, you have enjoyed this video and learned something new.